The course is Java programming, that is a core Java programming. So as the introduction of the course, I will explain you the importance of programming languages, what are the various programming languages, and where does Java fit in those set of programming languages, and what is the role of Java. We will understand this first because there are many questions like, shall we still study Java? Is Java still is in use or not? What I can do by using Java? Is the industry still using it or not? There are various questions, so we'll get answers to all those questions. First, we will understand the purpose of Java and the importance of Java. And then we will start learning about core Java. Then I'll give you the introduction to core Java, and that's how we'll start. So let us first get some introduction about an overview of all the various programming languages. Let us see. See, if I categorize programming languages, there are two, that are general purpose and special purpose. This is one way of categorization. You can categorize them based on different criteria, right? So this is one of the categorization. General purpose languages are those by using which you can develop any type of application, or I should say all type of applications. Special purpose programming languages, they are meant for some specialized task. They are meant for limited usage. So let us take some names of the languages, through that we can understand what does it mean by general purpose and special purpose. Under general purpose languages comes C language, C++, and there is also called as one language called Visual C++, Java, and C#, Python, and so on. And before C also there were a lot of languages that are developed, hundreds of languages I should say, that is more than 100, around 200 languages were there before C came. So all those languages were, most of the languages were general purpose languages, and one of the language that was very much famous, that was, okay, I will write it separately, COBOL, Common Business Oriented Language. This language was not general purpose, but it was used a lot. So I am not putting into this list, but I'll talk about this one also, so you get the importance of Java. See, I'm trying to focus on one point. That is, if you know what has happened in the past and present already, you'll be knowing definitely, and then you can predict the future also if you know what was there in the past. Past and present, with this you can predict the future. So let us continue. Special purpose languages. Under special purpose languages, that is JavaScript, PHP, JSP, ASP.NET, so on. Or there is one more, nowadays it's not in use, that is called as ActionScript, and so on. Now let us see what does it mean by general purpose languages, what you can do. So here I will make a list what you can do using general purpose languages. See, using general purpose languages, you can develop business applications. Business application means an application for any kind of business. That may be a bank, that may be any manufacturing company, that may be any transport company or airline, any type of company, or for grocery store. You can develop an application that is useful for their business working. So business applications you can develop using all these languages, but in some languages very easy to develop application, in some languages very difficult to develop the application. So this COBOL, Common Business Oriented Language, this was used for this purpose, that is developing business applications only. It is not for every type of application, it was meant only for business application. Around the globe, When the computers were introduced, this was the language that was ruling computer industry or software industry. Every company was using some software that was developed in COBOL only. This was the scenario till late 1990s. Every company was using COBOL. That was ruling over. Like few years back, Java was ruling. Now Python is booming up. So just how Java was there for a very long time, COBOL was also there for a very long time. Then what are the other type of applications that it can develop? Now commonly we see that web applications, web apps. You can develop web application using all these. And what about these languages? These languages are meant only for web applications. So commonly known languages I have written here, they are meant only for web application. They are not useful for any other purpose. So that's why these are special purpose languages. They are not useful for any other type of application except this. So can I develop those things with web application using C, C++, Java? Yes, Java means JSP only and C# means ASP.NET only. So can I use C, C++ also? Yes, you can use C, C++ also for developing web application. Initially, when websites were under development, when business was growing, application development was growing, C was the language used there. Perl was the language used there. Later, when Java came, people started using other technologies. Otherwise, C is the solution for all type of problems in computer sciences. So C or C++ we can say. Next is distributed applications. Distributed applications means what? Okay, I'll add one more. Client-server applications. Client-server applications. What are these client-server and distributed? They may be mostly useful for, again, business purpose only. This is not a category based on the type of application. This is based on the architecture. See, businesses use the applications like this. They will have one server and many clients connected to this server, and all the clients are using this server simultaneously. That is, everything, applications, database, everything is on the server. So this type of application that are client server. And here there are more than one servers connected in a network. More than one servers are there that are connected in a network, and the users are connected to the network. I will not show them connecting to the server machine. I will just join them to the network. Okay, clients, many clients are using this one. So now these servers, many servers, they may be spread across the globe on a bigger geographical area, forming a LAN, WAN, MAN, or internet. LAN means local area network, wide area network, or internet. All right, metropolitan area network or internet. So they will be spread across a very big geographical region. So today internet is nothing but distributed application only. It's like a distributed application. So we can develop distributed application. So the best example nowadays that we are using is YouTube, Amazon, eBay, right, or Google, Facebook. These are all distributed applications that are public use distributed application. So businesses are also having their, companies are also having their distributed applications. Like if you buy a mobile phone or Apple mobile phone here or Samsung mobile phone here, you can claim its warranty anywhere in the world. So it means that entire data is in single place. So it's not single place like client server, it is distributed in the network. So it's lying somewhere which can be accessible from any part of the world. That's it. This is the business application. So now I'll come to the point. When the distributed application started, one point. Client server applications, when this type of architecture was used, COBOL was used here. This was ruling here. And when the internet started growing, people thought of why to have a single server and so many clients connected to it. See, if many people are connected to it, we need a very high configuration server here. And the cost of having a very high configuration server will grow like anything. The cost will be very high. So instead of following this type of architecture, people started using distributed. See, it is just like one he-man, a powerful man, or 10 normal people can show the power same as one he-man. So that's it. having 10 different normal computing machines, average computing machines. You can connect them together, and the benefit is that they can be anywhere in a geographical area. You can connect them together, it becomes a distributed system. So when this type of system started coming into picture, this has given a solution and this has given a solution, right? So Java was introduced when people were starting to develop distributed application. So before Java, who was ruling software industry? COBOL in business applications area, business application area. All right. So these are few I have written. Now this I have related this with the business application. Now business application, this distributed applications, we find them actually nowadays on web. So all these are interrelated, right? Now next is we can develop games. You can develop games using any of these languages. Like nowadays C++ is at a boom for developing games. People are learning C++ and developing games using that. And in this, these are not meant for developing games. If you want, you can use them to some limited extent. They are not general purpose languages, they are special purpose languages. Then we can develop networking applications. So the applications or tools or utilities that are useful for this type of architecture, that is for maintaining or managing that one. So you can develop those application, networking application, or the application like chatting service or network gaming service, that type of things that you can do using these languages. And one more thing is system application. System applications. So system applications or system software, I should say, like device drivers or the tools for managing your devices, right? Like formatting a disk, format, or developing operating system itself. So very core level applications you can develop using these languages, but in that this will not come. Only these languages are useful. C, C++, and VC++. So you cannot do system level programming using Java. For system level programming, you have to use C, C++ only, because Java is a platform independent, whereas for system level, like on Android, for Android like operating system you want to develop. So for that hardware, you need some language that is dependent on that hardware. So yes, C, C++ is used there. Java or Python or C# will not help you there. They're not meant for system level, though they comes under general purpose, but this is one limitation on them because they are not hardware dependent. So I have listed few types of applications here so that you can develop using these languages, and these are just for web. And one is remaining in the list, that is ActionScript. Actually, this is useful for developing animations. This is useful for developing animations. This is not in use. This was there for some time. So this is the difference. Now I have shown you the importance of Java, that Java has captured the business application market by removing COBOL and coming from client server to distributed applications. All right, just this is an overview, no notes required. Whatever you have heard here, you can note down. Right, whatever I have discussed, you can note down, you can make few points by yourself. All right, I may not be dictating because this is just an overview. Achha, one more thing here is that these languages, Java, C# and Python, actually these languages are called as managed languages. Managed languages. Managed languages means these languages are little bit simple compared to C, C++. Right? So in C, C++, everything you have to take care, but in Java, Python and C#, interpreter or the runtime environment of Java and C# will take care or manage various things that makes the programming easy. So I'll come to it. I'll discuss about that at some time, why it is called as managed language. All right. So Java was introduced when internet was at boom, when internet was starting. There was a need of some language which works in distributed application and it works on any operating system. Now, one more point I can tell you that if you're having a single machine, then how many operating system you will have? So this famously, this was used, Unix was used. But when we say distributed application, like imagine that ICICI Bank, if you take an example, commonly seen in India, that is ICICI Bank, various branches are having some server. Every branch is having some server. Now, South Indian branch will have Windows server, North Indian branch will have some other like Linux server, or Eastern Indian branch will have some Unix server. Now, later they thought that let us connect all of them and make our own network. Then, the problem is the servers are different. They did not make any standard. They said that no, all should follow Unix or Linux. There was no such standard. Whatever they wanted, they were comfortable with. They adopted that same operating system. Then later they realized that we cannot connect all of them because the operating systems are different. See, remember, it's not easy like on your laptop that just we format and install another operating system. It's not easy for business machines, the machines that are used in businesses. You cannot simply remove them and replace with another. So it takes a lot of efforts for doing that because lot of important data will be there which cannot be easily shifted or ported on another type of operating system. So this is the reason they wanted some solution. Every company around the world wanted this type of solution such that they want some language so that at least in future, whatever the work we are doing, it should be compatible with various operating systems and we should be able to form our own distributed application or distributed system. On that they can have distributed application. So that was a need. It was a need in late 80s. This thinking or this requirement started, and early 90s Java was introduced. And Java, actually the purpose of introducing Java was different, but fortunately it was helpful in developing business application. And this became very famous. Now Java lies in this list. So as what all you can do using Python, that you can do using Java also. No doubt you may be doing a little bit easy in Python and more difficult using C language. In Java is average. And Java, they are trying to release new and new versions to make it more and more simple. That's it. So next I will talk about the features of Java programming language. So meanwhile, you can copy this thing. What are the points? I will just repeat the points. See, programming languages are categorized as general purpose languages and special purpose languages. General purpose languages, you can develop any type of application. Special purpose languages, they are meant for only special application. And one of the languages that doesn't fit in the category, it can be taken as special purpose because it is meant only for business application, that is COBOL. And these are the various, some of the types of applications that we can develop and who supports what. I have shown you that these supports all type of applications, and Java, C#, Python cannot support system applications, and these all are meant for web only, and there are some for animation, there are for various purposes, various languages are there, right? I don't want, you can browse through net and you can find out. I don't want to elaborate and discuss about them. Many languages are there. And mostly these languages are scripting languages. And where COBOL and Java, I have compared them. COBOL was ruling on this architecture. Java has started supporting this architecture. So you can write down few points. I have just repeated them quickly. Okay. So it's like dictation only. You can take it. Copy this. Next, buzzwords of Java. This topic is mostly found in the textbooks, and even in academics also teachers tell about this one. And mostly people start with this one only. So as a formality, I am starting this. So what are the buzzwords? That is nothing but features of Java programming language. Features of Java or buzzwords of Java. Means mostly talk about words. Java is simple. Java is object oriented. Java is interpreted and it is portable or platform independent. Java is secure. Java is robust. Java is architectural neutral. Java is distributed. And Java is multi-threaded. And Java is dynamic. There are so many things. Actually, I prefer talking about this buzzwords once we have finished Java. So again, I will cover them once we finish core Java topic so that we can realize these buzzwords and we can talk or know strongly about these words. So what I am going to do now is just briefly discuss about them so you get some idea about them, right? As a beginning stage. Then you can talk for hours together on each topic. Once you have the thorough knowledge of core Java, so you can talk for a very long time on this one and you can write passages on this one. So let us talk a little bit on this one. See, they claim that Java is very simple. The reason they said that Java is simple because the people who are coming from C++ programming language, the syntax of Java is same as C++. So that's why it is simple. This is one reason. And the second reason why Java is simple means like C++ was much used before Java, right? Not for all purpose, not for business applications mostly. It was used at like COBOL was also there. So C++ was slowly replacing it, you can say. So C++ was taught in academics as well as it was used for development. So C++ is having pointers, C++ is having templates. So these things were removed from Java and Java became very simple. So pointers are not there in Java. Templates were not there in Java in the early version. Then later on they started using it and calling them as generics. So templates were not there, right? Initial version. So these buzzwords are for old version of Java. What does it mean? I will come to that one also. So Java is simple in this sense. So if you already know C++, you will feel very comfortable and very easy in Java programming. Then Java is object oriented. Like in this C language was not object oriented, it was procedural programming language or modular programming you can say. Then later C++ which became object oriented language. So there are some object oriented programming principles, so that is abstraction, data hiding, encapsulation, inheritance, polymorphism. So these are some principles that are followed by languages, and if a language is following it, it's object oriented. So Java is object oriented language. Mostly people argue on this one whether Java is pure or not. That is another discussion. Why in my discussion I will come to that point also. I'll clarify that one also, whether it is pure or not. Right away I cannot explain you that one. I cannot convince you on that point. We will learn about this one. So Java is object oriented. So for time being, let us say it's pure object oriented, whereas C++ was not pure, but Java is a pure object oriented. Okay, whether it's pure or not, later we will decide. Okay, we'll have a debate on it. Then interpret it. Now, there is one more thing. Now I have to elaborate this one a little bit. Let us see. See, when you write any program, for example, you wrote a program in C language, first.c, then you will compile the program. So you get first.exe. Whereas if you write, I will not take example of Java, I will say first.javascript program, then you will not compile it, but you will interpret it. What does it mean? See, compiler will convert this high-level language code to machine code, and this machine code will execute directly on the machine without the help of compiler and without the requirement of .c. Whereas interpreted languages, if it is interpreted language, then this will run inside interpreter. So who is the interpreter of JavaScript? Browser is interpreter of JavaScript. So I have to discuss this topic separately. I will finish the buzzwords quickly, whichever are simple in 1 or 2 sentences I can finish, I'll finish them. Then I'll come to this because this is a very important topic. So this runs inside browser, and whenever you want to run, you need a browser as well as you need source code. So that languages are interpreted. So Java is also interpreted language. Java is actually hybrid, which is compiled as well as interpreted. It is compiled as well as interpreted. So this is over. Now Java is portable. How it is portable? Why it is portable? I have to elaborate this one. I will elaborate. This is required in the beginning only. These two topics, we need them in the beginning only. Object orientation, when we come to object orientation, we'll dive into that complete OOPS concepts that time. But now I will be elaborating next to this one. Then portable, platform independent means it can run on any operating system. You know it well. Then Java is secure. Secure means what? See, there is a chance of virus, there is a chance of spyware, or there is a chance of attack on your program, or malicious software attacking your program. Like you are commonly aware of this spywares and these things. So these cannot harm Java programs. Reason, like little bit knowledge you may be having, that Java programs doesn't run independently, they run inside JVM. That's why we call Java programs are managed by JVM, that is Java Virtual Machine. So Java Virtual Machine will protect Java program from any foreign or external attack on the program. So no program can interfere, or no malicious software can damage your Java program or affect your Java program because it runs inside JVM, right? This is the claim from that is Java, that Java is secure. Then robust. Robust means what? See, have you ever came across a problem that you were using some software for continuously and you already have done some important work, suddenly your program closes and you get a message that there is some problem. Do you want me to report it to Microsoft, or do you want me to report it to Apple? You get a prompt like this, and if you say yes, then a report is sent or not, we don't know, but we get that message. The point here is that we lost the work that we have done. Have you ever faced this problem? Yes, you have faced this problem, and this is a exception, a runtime error. Suddenly your program has a stop. So program was weak, which cannot sustain a severe problem in your application. There was some severe problem because of which it has suddenly stopped. So that's what your program is not strong. So in Java, if you develop any application, Java programs will not terminate like this. Suddenly they will not terminate. If it is terminating, it's not written in Java, it is using some other language. So Java programs will stand strong even in worst cases. At least they will give you a message that I am facing this problem. Do you want me to continue or stop? That's it. Java programs are robust, strong. How they are made strong? This again we will learn about the topic, that is Exception handling. Exception handling makes Java programs strong. The next, architectural neutral. So what is architectural neutral? Java program can run on any hardware. They are independent of the hardware. They are independent of the operating system, first of all. So even they can run on any hardware. And one more thing I'll tell you, there are some software architectures. You may not be knowing this, just a little bit I want to tell you. You might have heard about one architecture called as MVC, Model View Controller Architecture. Architectural neutral means MVC. Before Java, when C++ was in use, that was VC++, that was following some MVC architecture. You might have heard of Spring or Struts, which works on MVC. So Java claimed that I'm not dependent on any architecture. You can use me for any architecture. Like strut, if you say, no, I don't want to use MVC, don't use struts. If VC++ language, like VC++, still it is there, still is in use. It's not dead, but people are not learning it. It's in use, VC++. So if you develop in VC++ and say, I don't want to use if you don't want to use MVC architecture, leave it. Don't use VC++ at all. So but in Java, you have an option whether you want to use any architecture or not. That's up to you. So what is architecture and all, that's a different story. At one stage, I'll explain you that what is MVC and how you can use it in Java also. So Java is architectural neutral. It's not dependent on any architecture. You can use it on any hardware architecture and you can use it for any software architecture. Then distributed, already I have discussed about the point just now that Java has supported distributed application development. Then Java is multi-threaded. So multi-threaded programming, again, I cannot say anything right now because unless I tell you what is a thread, what does it mean by multi-threading and all, so we have to elaborate when we come across the topic. So Java supports multi-threading. C++ or C++ also supports multi-threading. C also supports multi-threading, not the basic version of C language. The later new versions of C language that are supporting like Microsoft C language, Microsoft C++, they support multi-threading. There are some APIs using that you can develop multi-threaded application. So Java has built-in support for multi-threaded application. So you can run multiple tasks simultaneously as threads and you can perform tasks or any application efficiently. Multi-threading is there. Then Java is dynamic. Java is dynamic. Dynamic in what sense? There are various sense of dynamic. Like Java program running on one machine, just you want it to move on another machine, just you can move it on another machine. In the running state only you can move it on another machine. This is one thing, one example of dynamic. Then another example, in Java, always the objects are created dynamically in heap. That is another sense. So easily you can modify the applications of Java, existing application. In that sense also it is a dynamic. So it is dynamic in various ways. So Java is dynamic. So that's all about the buzzwords. I quickly repeat again, no notes on this one because I said that there are few points that have to be elaborated and you can write pages on that one. So quickly one point I will tell you. Just you take it and you can copy this. You can write down in your own words. Java is simple because it's coming from C++ syntax. It's taking same syntax. It's OOPS, object oriented. It's interpreted because it runs inside JVM. Actually, it is hybrid. Java is hybrid. So our next talk is on this one only and this one, right? So Java is interpreted, that is hybrid. And Java is platform independent. It can run on any operating system. It is secure by JVM. It is robust because it has a strong exception handling. Architectural neutral, it can run on any hardware and any software architecture it can adopt. It's a distributed, the point which I have already discussed just now, it is useful for distributed applications. Then it is multi-threaded, supports multi-threading, and it is dynamic. So you can list down this point, just one sentence you can write down on this one. I don't think I have to dictate on this one. So write down about this one, take the list Then we'll come to these two topics. We'll elaborate. I'll have elaborate in detail. Mostly students don't know about this and don't know about this. So I will nail down everything in this form, right? Next, I am going to discuss the difference between interpreter and compiler and how Java is hybrid. This is very important point. You must understand this clearly, right? Let us see. Compiler versus interpreter. See, basically languages are categorized again based on two things. Some languages are compiled languages, some languages are interpreted languages, and some are hybrid. Let us take some example. Compiled languages. Compiled languages, they are C, C++, right? COBOL, this was old language. These were compiled languages. Then, what are interpreted languages? Interpreted languages are JavaScript. Okay, I'll write complete name. JavaScript, PHP, JSP. These are interpreted languages. Now, this language cannot be compiled, this language cannot be interpreted. They belong to different category. Mostly interpreted languages are scripting languages, mostly. First I am categorizing, then we will see what is compiled and interpreted. Then there are hybrid languages. Hybrid. Who are hybrid? Java is hybrid. C# is hybrid. VB.NET is hybrid. So basically all .NET languages are hybrid languages. All .NET languages are hybrid languages. So there are some compiled languages, there are some interpreted languages, there are some hybrid languages. So what are the differences? What does it mean? I'll explain. Just you can take a list quickly. Now let us understand what does it mean by compiled and what does it mean by interpreted and finally hybrid. Let us see. I'm throwing an example and explaining you like C language is compiled language. So suppose I have written first.c program, then if I compile this, then what I get is first.exe file. This is executable file. Compiler converts a source code to machine code, high level language source code to machine code. We got this machine code, and machine code is generated in a separate file. Separate file we get. Whereas if I write first.javascript, then it will run by interpreter. And who is the interpreter? Browser is an interpreter. Will I get first.exe file separately? No, I will not get. That's the first difference. See, mostly when I ask students what is the difference between compiler and interpreter, quickly they will say line by line whole program. But what does it mean? If I ask them to give the reasons and explain in detail, they don't know. They just know this definition because that is taught in first year of your academics, and they know that much only. They never explored it. So that's how the points are very important for you. Okay, you will never get a chance again to learn this, so listen carefully. If you compile any program, then that will give a executable file separately. Before that, it may be generating some other files also. We are not bothered about that. Finally, it gives executable file. This will not give executable file. First point. Second point. If this program is error free, then this will be translated only one time. One time translation. One time translation. What about this? This has to be translated every time whenever you run. If you run 100 times also, it will be translated for 100 times. Every time you want to run, it will be translated. Translated every time when it runs. Whenever it runs, it will translate. Okay? Always it will translate. So this translation is done only one time because you have a file now. You don't need this now. So one more point is no need of source file. No need of source file. You can delete this file because you have the program in the executable form. Unless you feel that no, I may need that file, later I may make changes and generate another program, new program. So okay, you can have it. Any updates you can have. Otherwise, basically you don't need it because you have a product now. Here, always source file is required. Always source file is required. Whenever you want to run, source file is required. If you ever have checked in any website, right click and say view source, you can see the source code of JavaScript. Because that is useful for developing web pages. Right click and see, you can see the source code of JavaScript. Though it will not be easy for us to understand because they know that source code is required for execution every time. They write it using some tricks such that a person who is reading should not easily understand how it is working. Otherwise, everybody will copy and use it. So their efforts will be copied by others. So for that reason, you cannot read it. Right click and see, you cannot read it. That is the reason. But source code is definitely required. Without source code, it will not run. So always source code is required. Then runs independent of compiler. You don't need compiler again. Only one time translation is done. So no need of compiler. Here always interpreter is required. Without interpreter or without browser, it cannot run. Always you require. So always interpreter required. It runs inside interpreter, so it's not independent. I should say it is not independent. It runs inside browser. That's one point. Then next point. See, this runs independent of this one, so this is faster. This runs inside this interpreter, so this is slower. These are the points. So always interpreted languages are slower. Java is interpreted also, so that's why it is interpreted, but it claims that I am not slower like other interpreted languages, I am faster than that. So Java is really faster than that, but slower than compiled languages. So Java programs are slower than C++ languages, C++ applications. So these are slower. Now where is the point? I did not mention that line by line whole program. So listen. How this works? Every time browser will take this source file, translate it, execute it, translate it, execute it. Every time it will translate and execute, program over, finished, stop. Again you want to run, again read one line, translate, execute. So that's how it is, line by line translation and execution. Always browser is required, always interpreter is required. Translation is done, execution is done. Whereas translation is done only one time. So whole program means translation is done for the whole program, that is done on only one time. That is the point here. So it doesn't make sense completely when you say line by line or whole program, doesn't make sense. So what is that line by line? Every line is translated and executed. Now I can give you one example. Suppose you have one letter, somebody sent you from China, somebody has sent you a letter and it is in Chinese. You don't know Chinese. Suppose I know Chinese, I can translate it for you. So what I can do is, if you bring a letter to me, I can read that whole letter. I can write an English letter and I can give it to you. Right? This is one method. If I write a letter in English and I can give it to you, how many times I did translation? One time translation. For that same letter, do you need me now again and again? No, independent of compiler. You don't need me, I am compiler. And do you need that Chinese letter? You have the English copy, that is least important. If you want, you can throw it away also because you have a copy in English language. No need of source file. And whenever you are reading, you don't have to come to me because you have an English version now. You can read it faster, independently. These are the points. Second method, if you bring a Chinese letter to me, what I can do is, I can read first line and say, he's asking, how are you? Next line, he's asking, how is your health? Next line, he's asking, how are your studies? So line by line, I am reading and translating and explaining you. That is execution, let us say. Every time I will read and explain, over. You have understood. You will go back. Again you want to read, again you will come to me. Again I will translate. So if you want to read daily I have to do translation. And that Chinese letter is important, you cannot throw away that Chinese letter. Right? File is not generated. The translation is done every time whenever you are coming to me. And always that Chinese letter is important. Always you require me, that is interpreter, and it becomes slower. Slower that I have my work. Same example if I take, I have my work also, it will delay, I'll say come tomorrow, come wait for some time. Anyhow, two people are there when that letter is read, myself and you. Means I'm interpreter and you are program. Two people are there, letter and the interpreter, two things are there. Here, when it is running, only program is there, there is no compiler, nothing. So these languages are much faster. Now one last point, last difference is that these languages are difficult. Reason, see sometime what happens, you wrote one C program, it is showing one error. You remove that error, it shows 15 errors. So it was showing first error, saying that first of all you remove this, I will see the rest. So you remove that first one, then it is showing 15 errors. Sometimes students panic, see sir, First was one, there was only one error, you did changes, now it is showing 15 error, means you are showing wrong. No, no. It was just showing you the first error maybe, or at one time itself it will show you all 16 errors, depends on the compiler versions, different versions are there in C++ I'm talking about. So if you remove all the errors, then only it will say, okay, it's fine, I will translate it, then successful you will get a machine code, that is exe file. Here, suppose you wrote 10-line program, and in ninth line there is a problem. So 8 lines it will execute. 9th line it will prompt an error. I don't understand what you have written here. So 8 lines will execute. That will help the programmer to easily trace or track where the thing is going wrong, and he can make changes. Because the result of 8 lines, he can see them easily. So these languages are easy. These languages are easy. These are difficult to learn. These are easy to learn. So you can take this. These points are very important. Before knowing Java, we are not directly jumping into the code of Java. So the points, you take them. Now, let us see how Java works and how it is hybrid. Let us understand this one. See, I'll compare again. I have first.c program. When I compile, it gets converted to machine code. Machine code. What is that machine code? I'll get a file that is first.exe. Just now we saw this. Now, one important thing. What compiler has done? Compiler has done two things. It has checked whether there are any errors. If there are any errors, it prompted you saying that there is an error in so and so line. You remove the errors. So compiler checked for the errors. If there are no errors, then it converted into machine code. So compiler has done two things. There are phases of compiler. I'm not talking about that. So broadly, I am categorizing into two tasks done by compiler. Checking for the errors. If there are no errors, generate machine code. Java programs. If I write a program using Java language, that is first.java, when I compile, then compiler will generate an intermediate code and it will generate a file called first.class. And this code is called as bytecode. Oh, what is this? It is not generating machine code. No, it doesn't generate machine code. Then what it is generating? Intermediate code. Can my computer understand this? No, computer cannot understand this one. Then what it has done, compiler, what it has done? What is the benefit? It has checked for the errors and removed the errors. So is this bytecode is executable, means ready to execute without any errors? Yes, it is ready to execute without any errors. What is this bytecode? This is a code understood by Java, given by Java, people who developed Java. It was by Sun Microsystem earlier, now you can say Oracle. So it is bytecode understood by Java language. Then where this code will run? So for executing this code, we need a interpreter that is called as Java Virtual Machine, and this will read this code and translate into machine code. So JVM is an interpreter. Yes, JVM is an interpreter. Interpreter means every time when I want to run my Java program, that is .class file, do I need JVM? Yes, you need JVM. What does it do? It will translate this bytecode into machine code and get it executed line by line. As we know already, interpreter, we say just now we have learn about it. Translate and execute, translate and execute. Is it not slower? That's what Java says, that though I am interpreter, but I am faster than other interpreted languages. Reason, those interpreted languages, they do two things. Check for the errors, translate into machine code. But here it is doing only one thing. What? Just translation. Who is checking for the errors? Already compiler has done it. That's how Java is having two steps. Compile, generate class file. Then it runs on JVM and it converts into machine code. So Java programs runs as a part of JVM, just like web pages runs inside browser that are visible for us on the screen. But JVM is not visible, just we can see the running of Java program. So that's how Java is having compiler as well as interpreter. So let me quickly repeat this one because this is not that important. You already know it. So you can note down few points on this one. I'll just repeat them. Java program, source program. Compiler will convert into .class file which contains bytecode. It is an intermediate code. They have given their own name, that is bytecode. Okay, it doesn't have any meaning in that one. Byte means doesn't have any meaning. Like your pet dog, you can give some name. So just how they have given bytecode as a name. So this is bytecode. Then when this will run, who will run this? It will not run directly on the machine. JVM is an interpreter which will convert this bytecode into machine code and get it executed. So this is executed by JVM. So two step, Java follows two step. Compiler does checking for the errors and makes error-free program. JVM translate that error-free program from bytecode to machine code. These 2 points you can write down. Take this picture.